talks are for. And so we went a different direction with this, and we took the crystal structure from, it was published in Science a while back this year, and we simply made barcodes on the C-terminal or on the cytoplasmic tail of the SARS-CoV-2 spike protein. So as far as we know, this doesn't have a biological function, and we tried our best not to change any amino acids, and we could create amino acids that now allow us to differentiate viruses at a single virion level. We did this a couple of years back with influenza with much success and could demonstrate where there were bottlenecks between aerosol and contact transmission. But here, we're going to look a little at transmission, but what I really want to get to is what is happening in all these tissues where we don't see plaque-forming units. And so just to orient you on what these graphs look like, so what we're looking at here is every barcode we have that represents more than 1% of the population gets its own color. And then all the other ones under 1% are accounted for in black here. And so what I want you to appreciate is this is our stock of virus. It's noteworthy to tell you that the furin site is intact in all of these tissues. That's important because the loss of furin site in hamsters does result in an attenuated infection. So we started with the stock of virus. We directly infect hamsters, and we have many, many of these. I'm just showing you one representative. But you directly infect a hamster, and then you co-cage that hamster with a naive hamster. And so this contact transmission is very efficient, 100%. But all I want you to appreciate here is that there is no obvious bottleneck between giving a stock virus to the animal and having the animal contacted to a neighboring animal, suggesting that the changes that we've made appear to be of no severe biological relevance, which is an important assumption that we're going to make. Okay, and so this is what the data looks like when we grab, so this is all from one hamster, and again, we have many more, but I'm just showing you a representative. But in the lung, we have this population of variants that have no obvious distinction biologically, but again, allow us to follow virions at a single virion level. And then we just simply look at all these different tissues where we can pick up viral RNA without the ability to pick up a single plaque-forming unit or even a tissue culture infection dose. And what I hope you can appreciate is that while there is some evidence of stochastic bottlenecking, this looks nothing like what it looked like for influenza. And in future talks, I'll put the two side by side so you can appreciate it. But if this were influenza, what you would generally see is if this were, say, a transmission event, you would see 3 barcodes take over the entire recipient animal or tissue, because that's essentially the bottleneck of getting to that tissue or getting to another animal. But here what we see is basically the entire population of virus is represented in every single tissue, which would suggest to me that one, you must have free-flowing virus. So it's not that you're stochastically killing a few pneumocytes and that edema that we saw was allowing a few virions to get into the bloodstream, and maybe the vast majority of infectious virus in the serum would be neutralized or destroyed, but every once in a while, in every, an unfortunate patient, a virus does take foothold in the pancreas, in the heart, in the brain, and that may very well happen and start an infection. But what this would suggest is that the blood or entry into the blood or dissemination to other tissues in any other form is really not a bottleneck, because if it were, we would expect to see individual barcodes dominate distal tissues, which is clearly not what we're seeing here. So this really does suggest that what we're talking about here is access to the entire population throughout the body, which would mean that there is no bottleneck anywhere.